All right, we're back. So, in addition to grabbing water, I'm also mentally preparing myself to do some CSS here. Yeah, I often find I end up spending more time trying to get the DOM to do what I want than writing my Elm code, which is kind of frustrating sometimes. But let's do this. Actually, okay, so here's one thing that might make this a little easier for the moment. I want to add a border style to the model, and we'll use that. I guess we'll use that to divide, or we'll use that to put between the images, but that'll also give us some clickable area to do our dragging from. Border size will be an int, so let's set that up. Then going into our initial model, border size, let's say 5 pixels. Oh, hey Martin. So I guess ideally what I'd like it to do for these images is to start out with them sized so that it's cropped to fill, I guess is the way it's usually described. So it would, in the case of this beetle, resize it so that the width matched the width of the frame. And then you could position it, or like you can pan around vertically is what we'll eventually get to, but I'd like it so that it's never possible for the edge of the image to be within a frame. Okay, so now to add the borders. So I guess I'd like to add the borders both around the edges. This black is not part of the image in my mind. It's just kind of an area so we can see what's going on. And then we also want to add the borders in between the splits. Let's start on the outside. So in view canvas, I'm just going to add another div here with the border size that I want, because I want it to be a white, maybe a tan border. Attributes.style border. Oops. 5 pixels, which is actually going to come from our border size, toString border size. I guess we'll have to pass in. Solid tan, is that a valid HTML color? Let's try it out. And border size, we will for now just make a parameter here. The other possibility I was debating is we could make a canvas record type, put both the border size and the canvas size inside of that, but I don't know if that's better at this moment or not. Okay, then here, model.border size. It's the top level thing. Oh, and I forgot to use the ++. Concatenate those strings. There we go. Okay, and then we need to subtract the size of the border when we draw the children. So here, we're going to have width equals size.width minus 2 times border size. Then we also need the height. Let's basically going to be the same thing. Size.height minus 2 times the border size. There we go. And then now we want to add the border between the splits. So in our horizontal split, here we're going to have a div, HTML attributes style, and we are going to have this, the width, toString size.width pixels. Then we're going to have the height be the border size pixels, and the background color is going to be the border color. Let's just make that a top level thing right now. Where did I use tan before? Here. Border color. And we'll stick that at the top for the moment. It really should go in the model, but we'll parameterize this for now. Oh, bye Shadowlink. Thanks for coming. Let's see. Right. Border color equals tan for now. All right. Did I everything ready? No. On line 101, we need to add border size as a parameter to this function. In this case, it's kind of a global thing, so it should be a separate parameter for sure. Oops, it's an int. And then, where do we call this? Several places, actually. So line 68. Here we're calling view frame, so we need to pass border size there. Where else? On line 93. Oh yeah, both of these. So whenever we recurse into the children, we need to pass that. And finally, line 98. I forgot to pass children there. There we go. So we've got our borders. Let's commit that. All right, so now, okay, here is the fun part, finally. I want to make this divider between the beetles and the tomatoes to be a draggable item, and whenever we drag it, it'll be able to resize this thing. Oh, whoops. See, I made one mistake here along the bottom. I forgot to account for the border size in sizing the children, so the border is overlapping the area. So the height of the bottom one should be the height of the whole frame minus the top height minus the border size. There we go. Let me just commit that again. Great. All right, so now for the dragging and dropping. So I was looking at on the Elm website. In the examples page, there's a drag and drop example down here. So I basically want to follow the same approach. So the way this works is that in this view, this little box, they do an on-mouse down listener, which they make with a custom decoder so that it can grab the absolute mouse position relative to the entire page, and it's able to grab that out of the JavaScript event object using these decoders. So this is kind of like obscure of how this works, but this is kind of a pattern you can follow in general for drag and drop. So whenever there's a mouse down on this draggable thing, we produce a drag start message. But then where do all the movement events come from? Those come from the subscriptions. And there's a function here that checks and says if we have a drag in progress, then we're going to grab any mouse movements and any mouse releases and convert those into drag and drag end events. And if there is no drag in progress in the nothing case, then we'll just do nothing. We don't need to be subscribed to the mouse events. So let's follow the same pattern. In order to do this, we're going to need the mouse package. I always forget exactly which user it's under. So here's mouse, user input. So this is ElmLang mouse. So we need to install this package to get access to the mouse module. Elm package, we can make this bigger. Elm package install ElmLang mouse. And then let's follow this pattern from the example and create our mouse down listener to create the drag start event. And rather than just a general drag start event, I'm actually going to call this one a drag slider event. So let's find the right place. Here's our horizontal split. Here's our divider. So here's where our event is going to go. html.events.on mouse down. And then I'm just going to take this. So what this does, this is actually JSON.decode.map, and drag divider start, and then mouse position comes from the mouse package. I believe, look at that, mouse position, this is a decoder. Yeah, so this is used to grab the X and Y coordinates of the mouse from the JavaScript event, which is happening. So let's try this out. I think I'll need to import json.decode, and I'll also need to import mouse. And I think I also need to define, and I need to import html.events. And then I also need to define drag divider start, which is one of our messages. We haven't had one yet. And this takes a mouse position. Okay. So we can click it, and I'm going to inspect, pull this up on the bottom, bring up the console, and whenever we get an update, let's log it out to the console. So we'll do case debug.log message of our message. And then if we get a drag divider start with a position, then we'll just do nothing for the moment. Cool. And every time I click it now, you can see it gets, if this is large enough, you can see, we get a start event with the position of the mouse. And the mouse position is relative to the entire page. Cool. So let's see, what's next? Oh yeah, I wanted to add one thing on the style of the divider, is to set the cursor to a north-south resize. And there we go, we've got a nice little resizing cursor. Cool. So we've got our start event. So here's how this is going to work. And again, I'm going to refer to this drag example from the Elm website. So when we click the divider, we need to store in our model that the fact that the divider is getting dragged, but we also need to store the location that the drag started from so that we can do calculations later. So we'll need to store that in a model, and it'll be stored as a maybe because there isn't always a drag in progress. Second, we need to start tracking the mouse movement events when there's a drag in progress and converting those into drag move events. Whenever we get one of those, we want to update the value in the model. All right, so let's dive into it. Let's see. What did I say first? First of all, when we do the mouse down, we want to save something in the model. So here's our drag divider start event. So whenever we get this, we want to update the model and set the drag state to be just the position. And that means we also need to add drag state to our model. Drag state is a maybe of a mouse dot position. And in the beginning, there is no drag state. That's why it's a maybe, to allow us to say that drag state starts out as nothing. And then when we get an update with a drag start event, then we'll set it to just the position that the drag started from. All right. So next, we want to change our subscriptions, which currently is always none. I'm going to pull this out to a function. Subscriptions. This takes the model. And we're going to do the same thing that was done in this Elm example, which is check our drag state, and if it's nothing, we still have no subscriptions, and if there is a drag in progress, then we'll let me grab both of these and do these both at once. We're going to track the movement events and also the up events of the mouse. So case model dot drag state of, if it's nothing, we'll do subscriptions dot none, and if it is something, and we don't care about where the drag started, sub dot batch, which lets us have multiple ones, mouse dot moves. Then we need a function to create a message, so we'll define a new message type, drag move, and then we have mouse dot ups drag end. Cool. And then we need to define these two message types, these two message constructors that we just used, drag move and drag end. Drag move also comes with a mouse position, and drag end also comes with a mouse position. And now we should fail to compile because we haven't handled all the message types. We need to account for drag move and drag end. So if we have a drag move event, then what do we want to do? First of all, we want to update the position of the divider. So we have our frame, and if the frame is a horizontal split, we want to change the top height of the value based on that. So I think we'll need to define a function for that. Frame equals apply drag to the current frame. And we're going to want to pass the vertical difference of where the drag started to where we're currently at. So to do that, that's going to be the model. Well, we'll have to destructure the drag state in order to get the position that the drag started at. So we need another case here. So model dot drag state of. So if we are dragging, then we'll know in the drag state where the drag started, and in that case we can move things around. And we're going to say start position dot using the vertical position, this is a vertical slider, dot y minus position dot y, which is this one. Let's call this new position or current position. And if we don't have a drag state, then fine, we'll just do nothing to the model. We'll leave it exactly the same. All right, let's see what I forgot. Apply drag. I didn't write this function yet. Okay, so we're depending on this function existing, and the type of this is going to take an integer, and then it's going to take a frame, and it's going to return a new frame with the vertical slider resized by this amount. So we'll call this y change in the frame. And then we'll need to destructure the frame because we need to handle each type separately. So if this is a horizontal split, then we have a top height, and bottom. So we're going to give back a horizontal split with top still being top, bottom still being bottom, but we're going to change the top height. Top height equals the current top height plus the change in y. Let me put a line break there. And if it's a single image, then we're just going to do nothing. The resizing shouldn't affect the single image. All right, let's see how I did. Case does not have branch for all possibilities. This is in my update function. I need to account for the drag end. So that should be easy. So drag end, end position. And for now, all I want to do is just end the drag state. So we'll take the model and say drag state now equals nothing. And we also have no commands to run. Okay. Yikes. Okay. Well, it's certainly doing something here. I think first of all I did it backwards. I subtracted wrong, so this should be current position minus start position is how much we want to change by. And second of all, I'm updating the current position every time, which means I also need to update the drag state so that in the next frame of movement we'll only apply the changes since the last drag event happened. I'm not sure if I'm explaining that particularly well, but basically whenever we get a movement event, we want to store this new position in the drag state so that in the next frame we're not like doubling the amount that we're supposed to be updating. Yeah, there we go. Got some nice dragging. Cool. I am happy with that. I will note also that this is not completely correct yet because we can only apply drags to the top level frame. So if we had nested frames in here, the dragging is not going to handle that yet, which I will show how to do that later because it's pretty cool. I like working with tree data structures. But I'm pretty happy with where we're at for the moment, so let me commit this. So we added drag state. We added a bunch of update functionality, which hopefully I didn't rush through too much. It's kind of like the hardest part to get your head around, but we added all the logic to deal with the drag movements. We added the cursor. We added the mouse down event, which again, this may be a little hard to understand, but I just basically took this from the drag and drop example on the Elm website. And then we also made our subscriptions subscribe to the moves and ups, and also we have it depend on the drag state, so we only subscribe if there's a drag in progress, and which you don't have to do. You could just always subscribe to the mouse moves, but it's a bit more optimized because then Elm will remove the event handlers if there are no active subscriptions. And then we also had to add ElmLang/mouse as a dependency. Okay. Horizontal splits can be resized. And I'll push that up. And then check here. Okay. Ooh. So next, I want to set it up so that we can pan images around. And I think before we do that, we need to fix the image rendering so that in this case, like the beetle is just repeating over and over because it's too small given the aspect ratio of the frame. So I'd like to be able to fix that. So let's deal with that first, and then once that's done, then we can add the dragging and dropping of the images within their frames to resize them. Okay, so to start with, we're going to concern ourselves with viewing the single image. So let's see, a bunch of people offered suggestions in the chat of how to deal with this. So we've got, okay, someone mentioned object fit contain for the image, and conditionally doing a background size, yeah, desired width auto, or a background size desired height. Yeah, I think that's the way we're gonna have to go. Ultimately, I don't know if there's a way to do this without knowing the size of each image, but if there is, that would make things a lot easier. But I'm going to go with an approach where we'll need to know the size of the images, and I want to put that approach in here first. And we're also going to do some trick here in the DOM to be able to find out from JavaScript what the actual pixel dimensions of the images we're loading are without having to know them in advance. But I'm going to start out with hard coding the image sizes. and then we'll do the size loading shortly, because it's kind of a cool trick and something that I've needed on other projects as well. So let's start out here by defining this record type as an image. So we'll have a type image, sorry, a type alias. Image is going to be not just a URL, but also it's going to have a size. And once we have that size, now in our view function, we can check, and let's see, how does this work? So in the case of our beetle, it's basically like, I'm pretty sure it has to do with the aspect ratios. So in the case of our beetle, let me grab the actual size of that image. Does it say the size in the title bar? Used to do that. Yeah, 960 by 637. 960 by 637. This is the beetle. And in this case, the frame is roughly 250 wide by 80 tall. So the aspect ratio, so 960 over 637 is 1.507. And 250 over 80 is 3.125. 3.125. So I believe this has to do with the relative aspect ratios of the image. Because at the exact, like the transition point is going to be where the frame size is proportional to the beetle size, which would be if the frame size were 960 divided by 637 times 80, so 120. So the perfect size that fits is 120 by 80. So if we take 120 and divide by 80, that's 1.5. That matches the aspect ratio here. Okay, cool. So that's a bit mathy than I like to get when doing front-end work, but I think that's the logic we want. Okay, and here is a case where the record destructuring can start to get a mess, because we have two things called size. Let's call this image now. And here, this is image.url. Okay, and we're going to have a case, or we're going to say if, actually we'll need a let. So image aspect ratio is going to be image.size.width over image.size.height, and we'll need to two-float those. And the frame ratio is going to be two-float size.width over two-float size.height. And then, as Martin noted in the chat quite a while back, we'll say if image ratio is less, actually greater than is the current case, frame ratio, then do what we currently do. Otherwise, we're going to do the opposite, do toString size.width plus px, and then the height will be auto. Ugh, okay, I hope I did that right. I not enjoy this part. Single image has too many arguments. This is on line 102. I mess up. Single image. Oh, single image takes an image now. Okay, and then on line 48, I think that's our init function. Yes, it is. Okay, so the Beatles, I noted down his size here, 960 by 637. Size equals width 960, height equals 637. And then the tomato plant is how large? Let me just grab the URL and go there. This is also 960 by 618. 960. Okay. Cool. That looks great. Hey, that's perfect. That is exactly what I wanted. Okay. I used to teach Java programming tutorials to middle school kids, and we would do lots of graphics to make games and stuff like that. So I've had to do a lot of messing with geometry to do that. I guess it paid off today. Okay. Correctly handle image aspect ratios. Cool. So now, on to more drag and drop. So here's what we want to do. When we have any one of these frames, we want to be able to click and drag the image and reposition it within its frame. So to start with, we're going to need a new drag start message for dragging the image. So let me add that to start with. Drag image start. And that'll also take a mouse position. Next, we need to generate this start event at some point. That'll be in our view, and whenever we view a single image, we're going to need a event listener for that. html.events.on, and this is going to be basically the same event listener that we used for the divider. So when we have a mouse down, we're going to JSON decode.map and create our new message type from the decoded mouse position that comes from the JavaScript event. All right. And now, my update function to handle this new event type. Let's go to update. So there's a couple ways we can handle this. We have two different types of things we can drag. So we could change our drag state to include some information about what type of thing is being dragged. Another way we could do it, which actually we'll want to do shortly, is to create a way to address items in our frame which can potentially have nested children. So actually that's the real solution I want to do, but I'll talk about it more in a minute. For the moment, the fastest thing is I'm just going to have a separate maybe field for dragging images, and we'll just call it drag image state. Model.drag image state. So that's going to be a maybe, the same as we did. Excuse me. doing an update function. We basically want to apply this function, or excuse me, store it. I'm getting all confused. We basically want to store this in the model as our drag image state equals just position when we get this event. And there's also no command. Then we need to add drag image state to our model. There's also a maybe mouse position. Starts out as nothing. And what do we have? Okay. Cool, so you can see changing down here, whenever I click in one of the images, we get that started. Unfortunately, we don't do anything with it when it happens. So here, we need to deal with the drag moves. This is going to be a little ugly at the moment, and we'll figure out how to refactor this shortly. So now, if there's no drag state, which we should rename to drag slider state, then let's check if there's a drag image state. If there is, then we'll do something, and if there isn't, we will do the nothing that we were doing before. So if there is a drag image state, we're going to need to change our model somehow. We're basically going to update the frame to apply an image drag of, actually we want both an X and a Y to be able to change. So we'll have X equals start position.x minus current position.x. Y is start position.y minus current position.y. And we'll apply that to our current model, the current frame from our model. And then, same as we did before, we need to update the drag state. And then finally we have command.none. Okay. So I will admit this is a telltale sign of some bad code, seeing all this nested. But I like to get it working and then look at how to refactor. So let's do that. And for this to work, we also need our apply image drag function, which is going to take an X and a Y and a frame and give back a new frame. And this will be change. That's the frame. And depending on what type of frame it is, we'll need to do different things. So here's where it's going to get tricky, because at the moment we've got two child frames inside of a split. But we'll deal with that momentarily. I want to deal with the single image case first. So if we have a single image, then we're going to return a new single image. And the image, I'm realizing we need some more data in. We want to make an offset. So let's go define that in our data type. So image is going to have a URL, the size of the image itself, and then we'll also have an offset, which is going to be a position. We need to define position which is going to have an X, and it's going to have a Y. Now back to our function, by image drag. Now we have a name for this record type. It's a position. So this is going to be our existing image, but we're going to change the offset to have an offset of X being the old offset plus the change, and the same thing for Y, offset.y plus change.y. And if we have a horizontal split, for the moment, we're just going to return the same framing. And let's see, on line 56, I bet that's my init function. 56, yep, okay, so our offsets need to start at 0. Or I guess I could start at whatever we want, but let's start them at 0. Okay. First of all, it seems like we're not actually getting the movement events. We are not, because our subscriptions function doesn't do anything. We also need to add a case for if our image state, model.dragImageState, is also a just, oops. Yeah, this is looking pretty messy too, so I'm seeing more and more clues that we need to refactor. Okay, so as I'm dragging this around, I can see the numbers changing in the bottom. Oh yeah, but we said that this doesn't work for nested horizontal images yet. So let's, for the moment, just show a single beetle image. Okay, cool. And you can see actually now the offset here. Oh, first of all, it never stops dragging when I let go. That's because we haven't implemented the drag end for this new type. So if we have drag image state equals nothing also, we need to reset that when a drag ends. Okay. So over here is the offset of the image. We can see it's actually changing as I drag around. So I'm going to guess the problem is that we are not looking at the offset when we render the image. So let's go find the image. View frame, single image. Okay. All right. So we need to use the background position. Let me try this out in the Chrome inspector and make sure it works. So we have our image here. We say background position at 10 pixels. Yeah, okay, that looks like that is what we want. And it also looks like we need to go negative for what I would consider a positive offset. Okay, so let's add our background position is going to be the X space plus the Y part. Okay, so the X space is toString of image.offset.x plus pixels, and it'll actually be negative of that. And then here we have the toString of image.offset.y. And I guess I'm going to guess that that's also negative. Yeah, there we go. So we can drag that around. Cool. So that took a little longer than I was hoping. I need to take another short break. And yeah, let's see. What else do I want to get through today? I know a lot of people were looking forward to the JSON API. So I guess I do want to get to that. I also want to fix this so that you can actually drag nested frames. So this works when the top level frame is an image, but it doesn't work if we have a horizontal split. And actually that's kind of cool. Like we'll have to add a way to address different frames within the tree of frames and see how to deal with that. So after this short break, I want to do that and then try to see how far we can get with decoding JSON and using an HTTP endpoint to do an image search. So we'll be back in a few minutes. And yeah, I'll be looking at chat for a few minutes too.